Hello. Okay, so let's start the today's session. Hello.
Hello.
Okay, so let's start
You
the
start.
today's session. Hello. Hello.
Hello.
Yes, sir.
Hello. Mr. Aman, you can start.
Sure, sir. Okay, just a second. So our discussion for today's topic is battery thermal solution and its simulation. So I'll just brief you about today's session. So today we'll be discussing about what is thermal battery thermal solution and what is the significance of thermal solution, why we require thermal solution, do we require thermal solution, yes or no. So each and every aspect we'll see, and what are the various technology involves for the battery cooling and all. And then we will be seeing some of the case studies for the existing automobile vehicles they are using. And at the end, I myself did one simulation along with one of my guide. So then at the end, we will be discussing about that particular simulation also, that how we come into the solution of that particular. And yeah, as we discussed, at the end we'll be having a look on the two different case studies, how that vehicle, how the BMW and Tesla vehicle they have used the battery cooling system. And at the end, me and one of my guide we did one simulation on the battery thermal solution. So we will be having that look also, how we did the simulation and what are the various setup that we have used and how we got the result also. Okay, so I'll quickly start the today's session. So as the topic, battery thermal solution and simulation. Let's start with first slide, which is battery thermal management. Now, before starting this particular session, I do have some question in my mind. That first question is, what is battery thermal management system, and why we do require the battery thermal management system? Okay, is it necessary to pay your attention or pay your time to learn about what is the battery thermal management system and what we basically require? Do we really need battery management system? So, all keeping all this question in my mind, I'll start the session. And during the session, if anyone have any doubt regarding any point, then you can ask me. You can stop me then and there, and you can basically ask me about your doubt. Okay. So as all this question we have in our mind, so we'll try to answer this question during the session. Okay. So let's start with what is BTMS. So BTMS, as we know, BTMS stands for Battery Thermal Management System. So let's see what is this. The goal of a battery thermal management system is to increase the lifetime of a lithium ion cells. Okay, so what exactly the things? So this is my battery pack. Okay, battery pack is nothing but it is a combination of cells. Combination of small cells. So this is like a battery pack. Here you can see these are the number of cells are present. Okay, if I count, so it will be almost like 50 to 40 cells are present. So what exactly happening here? First, when the electricity generation, like the electricity flow of electrons is happening, and some chemical chemistry is there in the cell. Okay, and continuously charge and discharge process is happening with the cell. So during this ions of the flow and during this operation, some amount of heat is generating. Okay, and this heat can lead up to the let's say 100 degrees Celsius. Okay, or let's say 120 degrees Celsius. If you talk about the temperature, like the maximum temperature of the vehicle, let's say the temperature limit for that particular cell, it is like a 120. After 120 degrees Celsius, cell might not able to work, or let's say there is very high chance of thermal runaway also. Okay, so what we want to make our cell, or let's say our battery pack, into a thermal zone where it will give us a optimum work range. Okay, so for the optimum work range we'll be discussing later. First, here the main point is to understand how the heat is generating, or let's say the rise in temperature, how is it actually happening. Due to continuous work of the cell, let's say battery pack, the heat is generating, and we need to cool this particular battery pack, or let's say individual cell, to get the optimum result, or let's say optimum performance. If it is keep on the temperature will keep on be generating, or let's say increasing, so there is a very high chance that your battery pack might not able to work, or there is a very high chance of thermal runaway also. Okay, so the idea behind designing a battery thermal management system is to increase the lifetime of a lithium ion cell. As here you can see, to increase the lifetime of lithium ion cells, and does the battery system by regulating the temperature level and distribution. So here what we exactly doing with this battery thermal management system, if the battery pack is in, let's say, high in the temperature is high, so we want to reduce this temperature to optimal temperature. Okay, to get the maximum output, or let's say the battery efficiency, for the battery efficiency, let's say. Okay, if your battery pack is somewhat less in temperature, considering the cooling condition, cold condition basically, so in a cold condition, so what exactly doing, they are basically maintaining a temperature. Okay, this is the main idea behind it. Okay, so there are so many processes which is happening here. At the same time, the main idea for BTMS is to retain the maximum efficiency of this battery pack, and at the same time taking care of the temperature and evenly temperature distribution. Okay, so let's moving on to the next thing. Next, the question is why battery management system is required. This is I have take one example. This is the battery pack of Toyota Prius. This is the vehicle. They have used this particular battery pack. So let's discuss why we require battery thermal management system. So battery thermal management system helps to keep optimum temperature of a battery pack using heating and cooling system. So here what we exactly doing here, we are doing two different operations. First one, we are heating also, and at the same time cooling. So as per requirement, we are using this both the operation. If the if the battery is working on a very high temperature, so basically we are performing a cooling operation, okay, to maintain temperature. Okay, this is up to between 20 to 40 degrees Celsius. Okay, next thing, if the temperature is very low, considering the low area, so we will be performing a heating temperature to attain this particular temperature. Okay, this is also called the room temperature, or let's say the temperature where the battery will perform like very highly. So for this, we do have one graph. So in that particular graph, we will getting a clear image how basically the temperature variation affects the life of the battery and what are the various things. Okay, so moving on with the during heating and cooling process, state of charge of the battery decrease. So here, if basically we are continuously heating or let's say cooling the process, the state of charge of the battery somewhat decrease. So thus battery thermal management system itself has both positive and the negative effects of the battery pack. So what exactly happening here? Suppose let's say this is a battery, and battery is only the power source in the entire vehicle. So if you want to run, let's say the battery thermal management system, if you want to run, or basically you want to cool the system, at the same time you are taking the power from the battery itself, okay, to cool the battery. Okay, so that's why the state of charge will be somewhat decreased, because you are taking the power from the battery itself to cool the battery only. Okay, so battery management system is having, like, at the same time it is having some positive sides, that it will be providing your battery to long and lasting life, or let's say it will be help your battery to maintaining a certain temperature where it can perform very efficiently. It will give you maximum output, but at the same time the state of charge, or let's say some amount of energy it will be taking from the battery, so overall it will affect the overall range of the vehicle. It's a performance of the battery at the same time, right? So think about what are the various challenges with the lithium ion batteries. So let's discuss what are the issues of the EV. Lithium-ion battery have high performance, but they are very difficult to manage. So here, very difficult to manage. Here we're talking about in terms of thermal management. This is very important thing because we know why we require thermal management system in order to retrain, in order to get the maximum performance. Here you can see in this image also, this is a battery cell. If it is keep on working and temperature is rising, so there is a high chance that it will might explode, or there is thermal runaway is also there, right? What are the various key problem here? So the key problem for the battery is dealing with the heat generation by cell during the charge or discharge and ambient conditions. Okay. So here we have three different conditions. What happens when in terms of charging the battery? When we charge the battery, so it will getting a electricity from the different sources, other sources, and at the same time it is keep on storing the energy itself. Okay. So during this process, flow of ions will happen. Due to this particular process, heat generation will taking place. Okay. Due to heat generation, the cell, or let's say overall battery pack, will be somewhat showing you rise in temperature. Okay. At the same time, while you're working on the battery, with the battery, if you are taking the power, so at the same time, your battery pack, or let's say individual cell, will be let's say showing you some rise in temperature. Okay. And as per the ambient condition, suppose you are running on a very hot weather, or the atmosphere condition is very high, so due to the surrounding temperature, uh, it might affect your battery performance, because as per the surrounding temperature, there will be very slight changes, so let's say high in temperature of the battery cells itself. Okay, so we need to take care of each and every aspect while you are charging. So at the charging time, your battery thermal management system is in an active mode. When you are running your vehicles, at the same time, your BTMS system is also working. But if there is any, due to a climatic condition or ambient condition, it is also need to take care of the battery. So what we want to retain a particular temperature, like let's say we can call it as a working temperature. So it is expected to be between 20 to, let's say, 40 degrees Celsius. This is your working temperature, we can say. Cell working temperature, you can call it as a. Yeah. Next thing is, what exactly happening when your cell is too hot? So during the process, if you are performing any of the tasks, like suppose if you are performing any of the operation, like if you're charging your vehicle. So what happened when the cell got too hot, or if you are discharging, or any due to any n number of conditions, let's say the vehicle is running, or let's say it is discharging, but at the same time, the rise in temperature for the cell is keep on increasing. The temperature of cell is keep on increasing. So what exactly thing will be happening? So here we can see it will decrease the battery life. This is the first and very most important thing. If the temperature will be keep on rising for the individual cell and as well as for the battery, so it will affect the battery life. Okay, it will decrease the performance. Okay, there is one study. If let's say, just for the sake of understanding, I'll give you some reference. Suppose for, let's say, a vehicle, it's like, let's say consider a BMW. Okay, BMW battery pack is there. Let's say it is having uh, 80 volts. Battery pack of, let's say, 80 unit is there. So if the temperature is, let's say, 10 degrees Celsius, and it is reduced by, let's say, up to -5 degrees Celsius. Okay, watt per hour. Okay, this is the unit. So what exactly happens if we reduce to the -5 degrees Celsius? So it will somewhat decrease the overall efficiency of, let's say, 35%. Okay, if somewhat the operating temperature is, let's say, 10 degrees Celsius, and it will somewhat increase to, let's say, up to 40, or let's say 45 degrees Celsius, it was somewhat affect your battery performance by 40 to 45%. So it will somewhat reduce the efficiency of your vehicle in terms of range. Okay, so it will give you some 80 watt hour of let's say output. Okay, so this is the thing. That's why you don't want your vehicle, or let's say your cell, battery cell, to be more cool, or let's say to be more hot, it should be in the working range. Working range also, right? Risk of fire and explosion. As we can see in this particular image, if the temperatures keep on increasing, so there is very high chance due to the internal chemistry of the cell explosion, or let's say a technical term, uh, thermal runaway will happen. Okay? So these are the things you need to take in mind while you will be working on your cell also. Okay? Now let's cover the battery performance. So this is a particular graph, so we'll come into the particular graph. But before talking about this particular thing, I'll just give you a basic idea about what is this C rating. So C rating is like that. Suppose I do have a battery pack of, let's say, 10 watt, 10 kilowatt battery. Okay. So 10 kilowatt of the battery if I have. Okay. And if I will be working on, let's say, a system with which by with a particular resistance, so let's say the operation, which help me to discharge this battery pack in, let's say, 1 hour. If I can, let's say, use an resistance, let's say any operation, or I can somewhat able to discharge this battery, 10 kilowatt of battery, into 1 hour. So I'll be working on 1C. This is a 1C rating. Okay. C rating is also responsible for the charge and discharge. Okay. If I want to charge this battery into 1 hour, so I'll be requiring 1C of charger. Okay. And at the same time, if I want to let's say discharge this particular battery into 1 hour, so I'll be working on, let's say, 1C. And if I'll be discharging this battery in, let's say, 30 minutes, so I'll be working on 2C. Okay, so you can do the calculation on the rest for thing. What is the 3C for the same, right? So this is just give you the basic idea of what is the C rating is. Now the next thing is the cold batteries discharge faster than the hot batteries. Yeah. Now what is the reason behind the cold battery? So here the thing is that if your battery is, let's say, too hot in temperature, so it will be somewhat discharging. But if your battery will be in a cooling condition, there is a high chance that it might get discharged by very efficiently, or let's say very fast. So what exactly happening when basically, suppose this is your cell. Okay, this part is there due to this electrolyte is there. Okay, this is your lattice, or let's say this is your membrane, which helps to pass the ions. Okay, so this is the plus side, this is cathode, this is anode. So what exactly happening when the temperature is low, or let's say considering the cold condition. Cold condition. So in the cold condition, what is exactly happening? This electrolyte is somewhat inactive, or this particular membrane will not help the ions to basically pass away. Okay, and with this, resistance will be high. That is why it will reduce the overall performance, and your battery will discharge faster compared to when battery will be hot in the nature. The most batteries can be damaged by explosive temperature and might ignite or explode if it is too hot. Okay, so this point, as we discussed in the previous slide, if you keep on let's say working on the bad temperature, if we will not provide any cooling, or let's say thermal management system, it is keep on working on a high temperature, there is a very high chance that thermal runaway or your battery can be explode. Okay. Refrigeration charges battery can help. Refrigerating charged batteries may help them to hold their charge, but it is best to use the battery normal room temperatures to ensure that the lasts longer as possible. Okay, so here what exactly happening considering this particular graph. So this is your temperature scale, and this is your cycle, battery cycle life. So here you can see the temperature is keep on increasing, let's say 80 to, let's say, 90 degree. So here, as you can see in this particular zone, let's say 15 degrees Celsius, this can contains of 15 degrees Celsius to, let's say, 50 degree. Okay. So in between, if you are working, so temperature range with a maximum life cycle. So if we are working on with our battery on a room temperature, let's say the temperature in between, let's say 15 degrees Celsius, let's say 50 degrees Celsius. This is your working range. Working range for maximum life cycle. Okay. So this is the thing, right? Now, if I'm working on the 1C, let's say 1C rating, if I do have a 10 kilowatt of a battery in and with the 1C, I will be reducing, let's say discharging this particular battery into 1 hour. So I'll be working on 1C as we discussed. So I will be getting a maximum life cycle. As you can see, it is up to near about not 1250, but it is near about 1240 or let's say 1230. Here we can say 1230. If I'm working on 1C. Okay, the maximum operating battery are under we are basically working on 1C or let's say less than 1C. Okay, for our mobile also we are working on less than 1C. But if you are using let's say very heavy software, if you are playing any let's say high resolution game like PUBG and all, so you see in your battery also it might show you some increase in temperature. Let's say it will discharge very fastly, but at the same time if you are using like if you are working on let's say very nominal thing, let's say if you are just playing just normally seeing the photos and basically just scrolling social media and all, so at the same time the battery performance will be high and you will be getting let's say high battery backup, or let's say it will be getting much time to discharge overall basically, right? This is the thing. But at the same time, if you're working on a 2C, let's say taking about the example, if you are it's a 10 kilowatt of battery you do have, and if you reduce discharging it in the 30 minutes, so that particular time what exactly happening, it will somewhat reduce the performance. And at the same time, talking about the battery life, if you are working in this particular temperature range, so it will be near about 1000. But if the temperatures keep on increasing, so there is a high chance that your battery life will somewhat decrease, as you can see with this particular curve with this green line. If you are working in this temperature range, so it will be like normal near about 1000 and all, it will give you a kind of high accuracy, high efficiency. But it is if you are increasing the temperature range, let's say about above 50 670, so you can say this is reducing drastically. And in 80 or 90 degrees Celsius, there is a high chance that your battery might explode. It's a thermal runaway is also there. But what happens when you are working on 3C, when you are reducing 3 times for your battery? So at the same time, you will be getting very less battery cycle, and there is a chance that like your temp, like if you are also working on the temperature range, so it will somewhat very reduce. As you can see, it is almost twice of this particular value that we are getting in terms of when we working on 1C. So this is also basically important what particular charge or let's say discharge rate you are working. So basically you cannot every time you cannot go for let's say fast charging, or let's say you cannot use your vehicle let's say your system for let's say very optimum range where you will be get you're accelerating very maximum let's say charge from the battery. So it will basically what is actually happening here, if you keep on doing a very high performance let's say operation with your battery, so someone the temperature is somewhat keep on increasing. Okay, so you also need to take care of the same time, because if you're continuously working on a very high temperature, so there is a very high chance that overall battery performance might affect. First point. Second point is the overall life cycle of your battery will decrease, and it will somewhat affect the range of the vehicle, because as we see, as soon as the temperature is increased, the performance get affected. And at the same time, if you are working on a cooler side, or let's say cold condition, where the battery temperature is somewhat decreased below this 10, as you can see here. If you're talking about this negative range, the temperature is somewhat minus 10 15, so it is also decreased here, but it is decreased in a very drastically nature if you compare to this both hot and this cold region also. So here you can see in the cold region it will be very less compared to this hot side. So you also need to take care that your battery should not work on a very hot side or should not be work on a very cool side. So there has to be some minimum balance is there. So what is this particular balance called? This is the temperature range of, let's say, 15 to 50 degrees Celsius. Okay, this is your working temperature for maximum battery life, and you will be at the same time you're working on 1C. Okay. This is the thing you should take care in mind while you'll be working on the battery performance. Let's moving on. Now discuss about what is the battery cooling criteria. What are the various steps that you can basically use to cool your battery. So first thing is phase change material. This is also called PCM. This is a very interesting let's say technique. We'll discuss this particular technique. Okay, so here this phase change material so can satisfy requirement at expense of a system volume. Okay, material cannot transfer heat away once collected, not a particular solution. Okay, so this we will discuss in upcoming slide, but this is just a short details about the same. It is effective, it is not that effective at the same time because it is coming with so many disadvantages, or let's say some problem is there. But for the two-wheeler, let's say three-wheeler, it is like quite a thing that you can use. So we'll discuss when we'll on next upcoming slide. Next thing is fin cooling. This fin cooling is somewhat like very familiar to us because in our two-wheeler normal commercial vehicle, or let's say in our day-to-day life, we are seeing so many things that there are so many applications for the fin cooling also. Third thing, which is called the air cooling, or let's say the forced convection. So in forced convection, there are so many things there that there is a one hot plate is there, and you are providing a very like let's say air in a very high let's say velocity at the same time. So it will providing some cooling effect. So this we'll discuss. Okay, fourth, which is very important, it's a very interesting thing here, just using liquid cooling. So you can also divide this liquid cooling into two different parts. First is a direct and second is an indirect cooling. Okay, just I will give you a brief idea about what are the different things about the fin, let's say fan cooling. So adds about 40% extra weight to the cell. This weight outweighs of the cooling benefits, not a particular solution also. Okay, next thing is air cooling, simple and easy yet relative crowd system need to two or 2 to 3 times more energy to the other solution, not effective solution also. So these three things, they are like a temporary solution, but it will not be a very useful, let's say, technique. Okay. Next thing is liquid cooling, high heat capacity and efficiency compared easy to arrange structure, delivered best optimum results. Okay, so in direct cooling, battery is submerged directly into the coolant, required coolant to be low or non-conductive, maintaining vehicle safety, not yet commercialized electric vehicle due to continuous R&D, heat acceleration. Yeah, so in direct cooling, it will be like very, it will give you very high accuracy. So we'll discuss this particular part, how will basically work and all. And in direct cooling, there will be one separate passage there. With this particular passage, you will be basically providing the liquid coolant at the same time due to the convection and conduction process. It will be giving you the, let's say, cooling effect. So we'll discuss one by one what are they. First we'll start with what is this phase change material. So this is a very interesting technique. This particular technique is not that useful, but you can use this particular technique in the two-wheeler and three-wheeler. Okay, four-wheeler I do have some doubt because I haven't seen any vehicle that are using this phase change material technique. So let's discuss what is phase changing material, or let's say technique is there. So this is my battery pack. Okay, as you can see, this is the battery pack. Okay, in this battery pack some black material is available. As you can see, this is black material is nothing but PCM material, so I'll name it as a PCM material, and this red is nothing but my cell only. So here you can see this is the casing for the material, PCM material. Okay, this is my cell. So what exactly happening here, let's get into the more details and try to understand what is this. This PCM cooling method is known as the passive thermal management system. Okay, so one another name for this PCM material is also called as the passive. Hello, any question?
Continue. Your voice is interrupted.
Now it's okay. Hello. Hello, Thaman, so now is my voice is okay? Yeah.
Now it's okay.
Yeah, okay. So yeah, we're discussing about this PCM material. So there is one another name for this PCM, let's say phase change material. It's also called as a passive thermal management system. So here what exactly happening? We do providing one casing for this PCM material. At the same time, this particular casing also, your cell is attached somewhat. Okay, and we are doing some connections here. This is secondary part, the connection and all. So PCM undergoes the phase change phenomena by absorbing or releasing the abundant heat from the batteries. So this is the very important point to understand here, because this will tell us the what is basically the working of the system. So here this is the cooling material is there. Okay, and just keep this thing in mind that we need to maintain the temperature, let's say in between 15 to 50 degrees Celsius. This is our working temperature. So what exactly happening? Suppose, we'll finish this last part, then I'll discuss this thing. This passive PCM cooling technology maintain the operating temperature of the batteries at the relatively constant temperature range. Okay. So here what exactly happening? Let's consider this scenario. This part we'll consider. So here, this is my cell, and this is the entire casing for this particular cell. This casing for a material, this is called a PCM material. So what exactly happening when I'm doing a continuous operation, or let's say continuous process is there, and some, let's say, charging process is there, let's say discharging process is there, or let's say if I'm running my vehicle, let's say certain speed. So what exactly happening when this process is going? So there is high temperature is there, or let's say the heat dissipation is taking place, or let's say the rise in temperature for the cell. So what exactly happening? This material is somewhat absorbing the heat from cell. So this PCM material will absorb the heat and it will change his phase. So it will be in liquid. Okay. This is a type of wax basically. This type of wax is basically thermally conducted and electrically non-conductive. Okay. So it is just basically absorbing the heat, and at the same time it is maintaining the temperature of this particular cell in between this working temperature. Okay, let's say earlier the temperature, let's say 30 degrees Celsius. Okay. So as per the 30 degrees Celsius, it is keep on melting. This particular metal is this particular material is keep on melting, and it is somewhat maintaining the temperature of this particular cell. So for the better understanding, you can have a basic idea in mind that suppose if you have, let's say, this jar filled with this particular water. Okay, earlier this water is nothing but into a solid form, let's say ice is there, or if you are providing some heat. Okay, so as far as you'll provide the heat, let's say the temperature is 0 degrees Celsius in this, and it is in a solid in particular nature. If it is keep on increasing temperature, let's say 10 degrees Celsius, let's say 20 degrees Celsius, so this ice will become melting. Just keep on melting actually, and what is actually doing, it is just absorbing the heat and it is maintaining the temperature. Okay, as soon as we increase the height, increase the temperature. Okay, this particular solid material will keep on getting into liquid thing, and it is keep on losing this let's say temperature. Okay, because it is absorbing the high temperature, it is changing his phase. So at the same time it is doing, but here there is one problem. When you stop the vehicle, so it is very hard to let's say dissipate this heat. Okay, as we discussed in this particular slide also, that it is not effective, because once the process is done and the vehicle is stopped, at the same time the heat dissipation is somewhat a difficult task. So here you can see this thing in this particular image action here, there is one aluminum plate is there. Okay, so as soon as the point is here that this PCM material and cell will be almost equal in temperature. And as we know, as per the Newton's law for, let's say, temperature, there has to be, if the, let's say, two bodies there, body A and body B, and if the temperature difference is less, so the heat flow is also less. Is less here. Okay, if it is, let's say, high in temperature, let's say the temperature difference is high, so the heat flow rate will be high. Okay, so with this particular material you can dissipate the heat, and at the same time it is somewhat not that efficient method to use. That's why it will be like suitable for, let's say, the small battery pack, or let's say the small operation that we are performing, let's say two-wheeler and three-wheeler, it will give you the optimum solution. But four-wheeler, I have a doubt that it might not up to that particular mark, or it might not basically give you that particular cooling effect that you basically desire. So what if I want to just sum up this whole PCM process into one line, then it is as per the temperature is increased, so the material is melting down and it is maintaining a temperature which is in between the working temperature. As soon as the temperature is increased, the materials keep on melting. Okay, so this is the thing. And when done with the process, so it will take some time to release that absorbed heat. Okay, that's all about the PCM. Let's moving on. This is a very interesting thing which is called fin cooling. So in this fin cooling, what exactly happened? This is my battery pack is there, and we do have some extended surface. In IC engine vehicle, this is also let's say a very popular thing, because in your two-wheeler you can you might see so many let's say application of the same. So for the two-wheeler segment, I'll just give you one brief idea. Suppose this is your engine. So in this engine, you might see some of the extended surfaces there. This extended surface is made up of the aluminum, because aluminum having let's say a high thermal conductivity, or let's say it is like very efficient when the thermal flow is, as far as the thermal flow is concerned. So this thing is there, and suppose this is the hot body. With this hot body, due to the conduction, okay, with this conduction process, it is temperature is flowing here, because this is the high temperature and this is in a low temperature. Okay, so as we know that as per the Newton's thermal law, that for the efficient thermal flow you do require a temperature difference. With the temperature difference, it is keep on flowing in this side, and here the air will take care of the rest. Okay, so this is all about the fin cooling. Let's discuss about this particular theory. What it says, that cooling phase increase surface area to increase the rate of the heat transfer. So here, suppose this body is there. Okay, so in this body, it will be not, the surface area is somewhat minimum, so it will not give you the efficient cooling. But if you will increase this extended surface, so it will somewhat, the area will somewhat increase. Okay, so as far as the areas increase, the heat transfer rate will also increase. Yeah. Next thing, heat is transferred from the battery pack to the fins through conduction, and from the fins the air through convection. So what here exactly happening? This is the extended surface, so let's say fins is there. Okay, so here this is the battery pack, and battery pack is somewhat hot in nature. So here we can say this is hot, or let's say high temperature. This aluminum fins is there. So this fins is taking the temperature from this particular body. Okay, so temperature is basically transferring from one body to another body due to conduction. Conduction process. Now there is some natural air is there. So flow of this particular air, we take this particular example here. This is the battery pack. Just a second. I'll erase this. Just give you a clear image. So this is my battery pack, and this is the extended surface. Okay. So what exactly happening? This is hot in nature. Let's say high temperature. This is low temperature. So due to the temperature difference, the temperature will be flowing in this direction. Okay, and due to here the conduction process is taking place. Due to the conduction, the temperature is flowing. But here air comes into picture. Okay, this air will take some part of this particular temperature. It is flowing. So here convection is coming to action. Okay, so due to the conduction and convection, this process is happening and this overall cooling effect is there. Okay, fins have high thermal conductivity and can achieve cooling goals, but they added a lots of additional weight to the pack. This is a somewhat more efficient process because here the thermal, or let's say the temperature difference is there, and it will be providing you let's say because the temperature is somewhat increased, but at the same time the heat distribution rate is somewhat increased due to this particular fins, and here the air come into picture, so the high temperature will be added to the surroundings. Okay, so you do have one let's say point where you can basically dissipate the heat, or let's say the rise in temperature. But at the same time, because since this is the aluminum part and you will be using it in it's a battery, so it having some its own weight, and so it will improve the overall weight. Okay, and cost and area. Okay, so that is why this is the thing that you need to take care of if you're using the fin cooling system. So at the same time, your let's say the overall weight of the battery pack will increase, the size will somewhat increase, and since this is the aluminum material, so at the same time the manufacturing cost, or let's say the overall cost will somewhat increase. Yeah, this is all about the fin cooling. Let's see what is this air cooling. So this is a battery pack. This is a 18650 cylindrical cell is there. Okay, now the air cooling battery thermal management system, BTMS, is one of the most common used solution to maintain appropriate temperature of the battery pack in electric vehicle. So this is a widely used. In a present study, the cooling efficiency of the air-cooled BTMS is improved through designing the flow pattern of the system. So this will discuss. So what exactly happening here? What they are actually doing? Suppose this is your battery pack, okay, and here we do have one inlet. This is the inlet part. This white surface is nothing but basically your inlet part. So here it is inlet part. You are what you are doing. Suppose the overall temperature of this particular, let's say, is near about 50 degrees Celsius, and here you are providing the cool air. Or let's say the cool air will be in between 10 to 15 degrees Celsius. Okay, so it is flowing, and here you do have some gap in between the cells. Okay, so as soon as the air enters and it is following this particular this white surface, what surface is there, so it is somewhat taking the heat due to convection. Due to this convection process, this cool air will taking some temperature and it is out from this particular outlet. Okay, so this is, you can call this as a forced convection. You can also call this because the air cooling, or let's say the providing air is on a very high, let's say velocity, and uh, now this is the thing, and at the same time it is like quite efficient, but it is not popular, and some engineers are also working, and you can basically improve the efficiency of this particular let's say air cooling system by designing, by improve it through the designing of the flow pattern and system. So you are basically improving this particular system, or at the same time you will So here, for the direct cooling purpose, what exactly happening here? So you will be submerging this particular cell into this liquid particular part, and there is one inlet and outlet is there. And with this inlet outlet pipe, there is one heat exchanger is there. So it will somewhat grab that all the heat is there. It will somewhat grab all the heat from the cells, and it will provide you some cooling effect. So this is a very highly efficient, let's say, uh, operation to extract the heat and provide you the cooling effect. But at the same time, it is still in R&D phase, and there are so many researches particularly going. There is no any vehicle which is coming with this particular idea, but yes, there are some vehicle which are coming with this indirect cooling part. So we'll be having a quick look what are the vehicles which will be having this particular indirect, and after that we'll be seeing on simulation that we have done. Okay, so this is one example of, let's say, Audi e-tron 55. Okay, so they are basically working on, let's say, indirect cooling, as we discussed in this particular slide, that there is a one part is exposed to the particular thing, and we'll be flowing some coolant which will help you to reduce basically the overall temperature of that particular cell and the battery pack that you have given. So here what is exactly happening, this is the intercooler is there, so low temperature cooler, this is a cooler is there. Okay, and there's one fan is there which is basically dissipating this particular heat into the atmosphere. So here let's talk about this particular battery. So the cooling the lithium ion battery during the DC charging. So this is the example when the vehicle is in a charging condition. Okay, so here what exactly happening, this is my battery pack. As you can see here, due to, if I'll zoom this particular image, it will be like same. This blue side, or let's say this dark side, will nothing but some small passages there. So here, as you can see here, this particular part, there are very small channels are there. So as you can see in this particular channel, right? So here there's a coolant tank is there, this particular part here also. Okay, at the particular point some coolant is will be there. So as the batteries keep on charging, so here you can see, due to the flow of ions, the rise in temperature. So let's say increase in temperature. Increase in temperature is there. So due to this increase in temperature, what exactly happening, it will somewhat affect the battery performance. So let's say battery range is performing, and let's say the energy storage capacity is also somewhat let's say disturbed with this high in temperature. So what exactly happening with this cooling operation? So this coolant, as soon as it is hit a certain temperature, let's say temperature is more of, let's say, 40 degrees Celsius, hit the 40 degrees Celsius. So this cooling process comes into picture. Okay, it will automatically generate it itself, and with this particular flow passes, the coolant is somewhat flowing in this particular direction with all the passage, and it is taking all the heat. Okay, and it is maintaining the temperature, let's say reducing the temperature, let's say near about 25 degrees Celsius, and that it will be in between the temperature working range basically. Okay, and when it is coming with all the area, it is taking all the temperature, let's say high temperature, it is coming into this low temperature cooler. In this particular cooler, this is also act like a intercooler when you're talking about like having a comparatively idea. Okay, so with this intercooler, there's small fins there. In this particular intercooler, there are small fins are there, and very, let's say, it's very fine pipe is there. Let's say 2 or let's say 3 mm pipe is there. And suppose this is a pipe, I'll just give you one idea. This is the pipe, and it is also filled with this fins. This type of somewhat is there, and there is one fan is there. Okay, so due to this particular fan, it is like a forced convection. So with this particular heat, there is conduction is there, and due to this air, the convection is there. So that's why it is providing you the high efficiency cooling, high cooling rate, we can also call it as. Yeah, this is a system that RD is using. Okay, this is also called as a indirect cooling. Yeah, let's moving on the next part. So now we'll discuss, as we see here, that it is like as per the battery pack, because they are using a prismatic cell battery. That's why they can able to use this particular thing, because in this particular thing, as you can see here, due to this particular cell, they are implanting this particular channel, and with this channel they are performing the cooling process. But what happened when we are using the cylindrical cell? Because in Tesla model S, you can see this battery pack is there and they are using some cylindrical cells. So with this cylindrical cell, they are also coming with this very unique idea, and this particular unique idea, they what actually they are doing, there is, this is the blue line, this is nothing but Tesla patented cooling tube. So this cooling tube is nothing but let's consider this is a copper tube. Okay, so this copper tube is there. So as you can see here, this is like a top view of the battery pack, and this is the side view. So it's the side view. We can see here, this tube is somewhat looks like that. Okay, and it is very close to that particular side wall of the cell. Okay, here I can say this also. This is the part. Okay, some, this is the inlet and this is the outlet. Okay, so what exactly they are doing? Let's consider this particular point. So here they are using a glycol coolant. Okay, this is the glycol coolant. So they are flowing this glycol coolant in, let's say, very less temperature. Let's consider temperature is 10 to 15 degrees Celsius, and the temperature of this particular cell is, let's consider about, let's say, 40 degrees Celsius. Okay, it is as per the keep on operation, it is like somewhat 40, let's say 45 degrees Celsius, and we need to also let's say decrease the temperature. So this, due to this particular thing, it is taking the heat from the side wall, as you can see here. Okay, and there's two different part is there. Okay, so for this particular thing, it will somewhat cool the half of this particular cell, and at the end with this is also taking care of the half of this particular cell. So here the temperature, let's say reduction, or let's say the overall efficiency of the temperature reduction is very high, because we here at the same time that this tube in let's say very less into the thickness, so it will be covering, or let's say here you can see it will be covering the maximum area, or let's say maximum surface of the cell. Okay, and there are two different parts, they have divided the upper part and the lower part. So the temperature, the area of contact is somewhat very high, and as we know that if the temperature difference is there and the surface, the contact area is very high, so you will be getting very high thermal cooling effect basically, or let's say the temperature, or let's say the heat, uh, traveling of the heat, or let's say yeah, it is very high in nature actually. Yeah. So this is the model that the Tesla is basically using, and at the same time they are performing, or let's say they are giving you a very high efficiency. And this is the reason that Tesla is the Tesla batteries are coming with so many, let's say the life cycle is very high, and the optimum, let's say, overall performance is, let's say, very high. Okay. This is the thing which is coming with the Tesla. Okay, so now let's see some simulation that I have do. I have did the simulation along with one of my guide. So I'll show the simulation. Yeah. So I hope the screen is visible. Just a second. Yeah. So let's discuss about this particular simulation. So this is my battery pack. Okay. This is the pouch cell. Okay, so let's see each by number by number what is the different things I'll give. So here I have imported this particular thing, and the mesh is already generated. So I have this is a pre-run simulation, so I'll just giving you an overview how I perform this particular analysis. Okay, so here this is the battery pack. Okay, let's discuss about the various part of the battery pack. So here, if you want, you can do the scale and checking the report in everything which is given to you. So let's go to the display point. So in this display, I will basically show you the various part. So let's start with this, the negative zone. So this is the negative part, positive zone. So this is the positive zone, the basic terminal. Right? This is the body, body. This is the negative terminal is there. This is the positive terminal. Okay, so here you can see this is the negative terminal, is that upper part or the negative zone. This whole part is like a negative zone. Now this is the positive terminal, and this is the positive zone is there. Okay, this is the wall. This is the overall wall of the particular cell. Yeah. So here you can see this is my cell body, overall cell body. This is the part which will be like basically separator. Here this is the positive terminal, and this is the whole positive zone. This one is the negative zone. This one is negative terminal, right? This is about the boundary condition. Talking about the model, so here you need to go to the model, and as soon as you will select on the battery model, this will coming in this updated part of the answers. Okay, so here I have did this CST coupling analysis. So in this CST coupling analysis, you just need to click on this particular part and enable the junction. And here there is some active and passive zone is there. Okay, and after that you need to just couple this negative terminal to the positive terminal. So what exactly we are doing here, this is my battery pack, and this battery pack having some, let's say, parameter. So this parameter is given. So the cell is basically nothing but 5 volt in the nature, and the total current is 56 ampere. Okay, so I'm using this particular cell. Okay, there is one resistance there because here I did connected this negative terminal to the positive terminal, and let's see what is the temperature range, or let's say how the temperature is basically working. This is the overall idea. So this is the thing, and after that you need to click on OK, and then it will be generated. And here you need to take the material. So this is the active material. You need to check on the material. Okay, so this is the material property. This material property is already known to you. Okay, so as per your analysis, you can give the material property here. Okay, and I did the same. And here you can change the cell zone condition here for the cell. This is the active material. So for the cell, you can basically change the material. Yeah. And for the boundary condition, you can give the boundary condition. Okay, let's check out the boundary condition that I have given. So here the boundary condition that we have given. So the thermal condition that we have given, this is the convection. Yeah, this is for the ambient temperature. So the heat transfer coefficient is 10 watt per meter square Kelvin. Okay. The overall free stream temperature, this free stream temperature is nothing but the ambient temperature is 300 degrees, 300 Kelvin. Okay. The wall thickness which is given to you already. Material name is aluminum. Yeah. So this is the boundary condition that we have given. Then we initialize this particular analysis, and we hit the run calculation. Okay, and let's check the results. So method I have used it, I have kept it as a by default method, so I didn't change any scheme FE solution here. It is just default. And in the report definition, I have used the average volume average temperature. So here you can go to the new and volume report. Okay. Here you can go to volume average, and you can basically just change volume temperature, or let's say static pressure, whatever you want. Basically, if you want temperature, so you can click on temperature and you can change. Okay, so I just created a temperature here, volume temperature, okay, profile, and then I initialize this particular analysis, and then I run the calculation. So I'll just quickly show the results. So here, if I'll go to the graph contour, there's one contour which is there. Okay, the temperature contour set temperature is there. Now I'll select the whole part and I'll select on show the result. Yeah. So this is basically the point is there. This is the legend view, and here, as you can see here, the earlier temperature is nothing but 300 Kelvin, but due to as soon as the cell into come into picture, it is performing the operation. So this is how it will generating. As you can see in the central part, it is somewhat showing the rise in temperature. At the side wall, this is very less in temperature. It's 535 Kelvin, and earlier it is like a 340 degree. Sorry, 340 Kelvin in nature. Yeah. So this is the overall simulation. So this is how you can do this particular simulation. I hope now you do have a particular idea how this particular simulation is taking place and how we can do this particular simulation. So that's all about my side for this particular analysis. If anyone having any question regarding the same, you can ask. Meanwhile, I can also share this particular thing that we as ISI India, that we are coming with so many let's say programs that offer. We do have some specialization program in EV engineering. This is basically for individual and the academy also. Okay, individual student can also perform. Individual student can also take into uh, part on this particular individual courses. And for the academy, we do have some different collaborative courses like 1+1, or let's say a tri-semester programs. Center of Excellence of E-Mobility Research and Skill Development Cell. We are also working on Center of Excellence. PG Diploma Program in EV Engineering, Certified Diploma Program in EV Engineering, training for student and faculty. So we do have some student development program, and it's a faculty skill development program also there. Summer internship and some online courses are there, and some free courses is also there. So you can check our ISI India website. So in the free courses segment, you will be getting so many free courses, so you can basically have a look on that particular thing. And we also have some certified diploma master program. So we are coming with some powertrain architecture energy storage system, and some discount is also there. And we are also associated with ASDC partner. This is our certification partner. So if you will be basically getting this particular courses, you will be also certified with the ASDC. This is a globally valid certificate. And we do also have some specialization courses in motor design, electric vehicle, and design and development of a hybrid HEV. And they are also coming with some summer internship is there, some 30 days, and let's say this is also individual and let's say institution based internship also. Yeah. So that's all about from my end. If you guys have any question, you can ask me, or you can put it on the chat box.
Knowledge and give us overview.
Hello, sir. Your voice is breaking.
Okay. Okay, now I'm audible.
Yes, sir. You're audible.
Okay, thank you very much. Very wonderful session you have taken, and very informative. You share good knowledge to us, but unfortunately, there are very few members. Mostly, they are faculties. It is especially conducted for the student. So same time there were one more lecture is going on ISRO. So senior faculty call them. So I think they switched there. So sorry for that, but we listen you, and very informative session. Thank you very much, Aman. Thank you very much.
Thank you so much, sir. Thank you, sir. Thank you so much. I'm just leaving the meeting.